Well, good morning, good afternoon, or good evening, Algebra Geometry 3 classes. First off, I want to say we do miss not being able to actually see you guys to present instruction here over these next several weeks now, but hopefully we will at least be able to see you back in school at some point before the year ends. But right now, that's kind of what we're all getting to experience now is this whole new concept of virtual school. We are going to get started into Unit 9 today, and basically it follows up our exponents unit, Unit 8, that we completed right before you guys left for spring break. And we're going to go over what is now called a logarithm. And a logarithm is just another way of rewriting an exponential expression. So I'm just kind of starting here with our definition. Well, if you have a logarithm of y with base b, a logarithm is denoted by log base b of y equals x. So again, you can see kind of here in parentheses, we say this as log base b of y. If and only if b to the x equals y, given that b and y are positive numbers, and b also cannot equal 1. And so if you happen to have a logarithm with a base 10, that is also what's called a common logarithm. We'll actually go over that when we get to the 9.2 portion of the notes, which I'll let you know where that occurs. And so when we work with logarithms, one of the things that you'll hear me refer to quite a bit is what's called a log loop. And you always start your log loops at the base. So you can see right here, log base b of a equals x. Well, we take b to the x equals a. So again, you take base, loop it over to the x loops to the a. So b to the x equals a. Another way that some teachers also talk about this is we say it's bacon and eggs. You take the log of the base of the answer equals your exponent. Well, log of bacon and eggs. So instead of base, bacon, instead of answer, and, instead of exponent, you have the egg. So just a little different way of a mnemonic that may or may not help you with that. But what we're going to do first is we're going to, again, using our log loops, rewrite a logarithmic equation in exponential form. So again, you always start with your base. So we're going to loop from our base over back to the number. So log base 2 of 32 equals 5. Well, that becomes 2 to the 5th equals 32. Again, log base 7 of 1 equals 0. We're going to loop from our base 7 to the 0 equals 1. If you remember, anything to the 0 power is 1. If you have done these questions correctly, you will get a mathematical statement that is actually correct. So again, if we come over here to example 3, log base 13 of 13 equals 1. So we'll do our log loop, 13 to the first equals 13, which again, you can even see this one is correct. 13 to the first is 13. So again, notice we're not solving anything with these. We are simply going from one form to another. Example 4, log base 1/2 of 2 equals -1. So again, I'm going to log loop 1/2 to the -1 equals 2. Now, if we were in class at this point, we would actually have you guys try a couple of these on your own. If you want, certainly feel free to hit pause on the video, work through those, with all of the notes. I will provide a hard copy. That way, if you do want to print them off as you're taking notes, you can. But if you just want to also watch 2 more examples now, you can. But if we have log base 18 of 1 equals 0, again, we'll set up a log loop. 18 to the 0 equals 1. And one final one, log base 2 of 64 equals 6. So again, when we do our log loop, 2 to the 6th equals 64. So those are going from logarithmic form to exponential form. Now, once again, you can do the same thing going from exponential back to logarithmic. Again, we can set up a loop. You always start with your base. So log base 16 of 256 equals 2. Again, that's how it's going to work with our loop now. So again, 3 to the 4th equals 81. So we start with our base, loop to 81, back to the 4. So we always start with our base. Log base 3, written as a subscript, of 81 equals 4. Example 9, 2 to the 6th equals 64. Well, again, set up our loop starting with the base. So now we have log base 2 of 64 equals 6. And one final example. So 3 to the negative 3rd equals 1 over 27. Again, we'll start with our base. Log base 3 of 1 over 27 equals negative 3. Once again, if you would like, again, feel free to hit pause as you're watching the video. There are a few examples on the next page that you can certainly try on your own if you want. Otherwise, I will just give you a few more examples that you can watch. So again, we have 64 to the 1/3 equals 4. So we'll do our log loop. Log base 64 of 4 equals 1/3. And once again, notice we are not solving anything on these. All we are doing is going from one form to another. 15 to the 2nd equals 225. Again, set up our loop. Log base 15 of 225 equals 2. And one final example, 2 to the negative 4th equals 1/16. Well, I'm going to write this one off to the side. Log base 2 of 1/16 equals negative 4. These examples correspond to the 9.1 assignment that you guys can now work through on Schoology. We won't have you do any worksheets. As long as you are working at home, all of your assignments will be within Schoology. You'll be able to work through those as many times as you would like to certainly better your score. But again, that concludes the notes for 9-1.